question. This is online question. So the problem is like this. There are two charges are there. Each of one. Each charge is 1 microcoulomb and 1 microcoulomb. Both are positive charges. According to the problem, A is the first charge, B is the second charge. They're separated by distance of 1 millimeter initially. So first one is fixed and second one is freely to move, right? And its mass is given 4 micrograms. It is given 4 micrograms. Now, when it is released, that means something we are holding like this and we released it. When it is released, what happens? Due to both are positive charges, there is a repulsion, they'll go away from it. Due to repulsion, it will go away. That means what is the velocity when this charge reaches to a distance of 9 millimeters? What is the velocity that we have to calculate? Hope you got it now. Yes? Yes? No? Boliye? Okay. Now, see here, when they are initially, these two are initially at a distance, it will have some potential energy. So initial potential energy K Q1 Q2 by R square. So I can write the K Q1 Q2 divided by R. K Q1 divided by R. U initial equals to K. K is nothing but 9 into 10 to the power of 9. 9 into 10 to the power of 9 into Q1 and Q2. 1 microcoulomb, 1 microcoulomb. Micro means 10 to the power of minus 6. Now 10 to the power of minus 6 into 10 to the power of minus 6 divided by, okay, divided by R. R is 1 millimeter, 10 to the power of minus 3. So what I'll get now, initial is 9 into 10 to the power of 9. This will goes to numerator, 10 to the power of, it will be 12 into 10 to the power of minus 12. So it means initial is nothing but 9 joules, right? So initial potential energy between two charges is nothing but 9 joules. Now, when it is released, as the distance is increasing, what happens to potential energy will decreases. Fine. See, as the distance is increasing, this is distance increases, potential energy should decreases. As potential energy decreasing, applying law of conservation of energy, energy neither created nor destroyed, disappears in one form and reappears in another form. Whatever loss in the potential energy will appears in the form of kinetic energy. That is the concept involved in this one. See, when it is taken here, what is the final potential energy? Final potential energy is the K Q1 Q2 divided by R. Here R increased, U final will be decreased. That means definitely after solving you should get less than initial potential energy. Now final potential energy, if I take final potential energy here, 9 into 10 to the power of 9, here 10 to the power of minus 12 divided by Q1 Q2, 1 microcoulomb, 1 microcoulomb, divided by R. R is nothing but 9 millimeters. 9 into 10 to the power of minus 3. These two will get cancelled. U final is equals to 10 to the power of 12 into 10 to the power of minus 12, which is nothing but 1 joule. Okay, final and initial. Now change. You can see clearly, observe, final potential energy is decreased when compared to initial potential. This change will give the kinetic energy. So according to law of conservation of energy, okay, so according to law of conservation of energy, so decrease in potential energy, which is equal to increase in kinetic energy, or it appears in the form of kinetic energy. So delta U is equals to kinetic energy, which is nothing but half mv square. Is it clear? Half mv square. Right? Half mv square. Now I'll erase this one. So what I'll get, can you tell me? Options I'm taking out. Otherwise, just to take a screenshot till this point. Yes, done. Take a screenshots. Okay, done. Sure. Now, if I calculate here change in kinetic energy, change in potential energy is equal to half mBVB square, because anyhow this is fixed, right? And there is no initial kinetic energy for the system. Initial kinetic energy is not there. Initially both are at rest, kinetic energy is 0. Finally, also the kinetic energy of AE is fixed, there is no kinetic energy. Now delta U is equal to 9 minus 1, which is nothing but 8. 8 is equal to half into mass of the charged particle is 4 micrograms. 4 micro 10 to the power of, okay, micro 10 to the power of minus 6 grams, 10 to the power of minus 3 into VB square, V square. This ones are twos, this ones are twos. So 2, right? Fine. 2 divided by 10 to the power, sorry, 1, 2, this is 4, sorry, this is nothing but 4. So 4 divided by 10 to the power of minus 9 is equal to V square, or simply V is equal to under root of 4 into 10 to the power of 9, which is nothing but V is equals to 2 into 10 to the power of 3 meter per second. Hope you got this answer. It's nothing but option D. Is it clear? All of you? Yes? Hope it is clear. No doubts in this? Yes. Good. Right. Now look at the boards. All of you. Now it is given in May 2019, 11th January online. This is based on electrostatic potential energy. In this question, according to the question, 2 small q charges are there, 1 capital Q charge is there. When this system, that means due to this system, electrostatic potential energy is 0. The net electrostatic potential energy is 0. Then find the value of Q is same. So just a theory while we're discussing just now, when there are 3 charges are there, we'll have 3 potential energy. 4 charges are there, 6 potential energy. 6 potential is there, 6 charges are there, 15 potential energies. Just now we discussed in the theory, right? So if I take here, we'll have 3 potential energies. So net potential energy of the system, if I take between these two, let me take 1 potential energy, here are 2 potential energy, 3rd potential energy. So U1 plus U2 plus U3, U1 plus U2 plus U3. Obviously, these two are same sides, A and A. This will be root 2 into A, right angle isosceles triangle, yes, given, right? So U1, U2, so net should be equal to 0, already given. U1 between these two, I can write a K Q1 Q2, Q square divided by A square plus, between these two completed, between these two, K Q small q capital Q divided by A square plus, between these two, capital K Q small q divided by root 2 A whole, root 2 into A, not A square, this is nothing but A, sorry. So this is nothing but A and root 2 into A. Is it clear? So option is D, correct only. Now what we require here, a 0 is equals to, I can take K Q by A as a common. If I take K Q by A, here we will be getting Q plus K Q by A, Q plus, I can write here K Q by A. This is nothing but K Q by A. If I take then capital Q by root 2, right? This one, this will become completely 0. Then K Q by A is a constant, cannot be 0. So Q plus Q by root 2 equals to 0. Or simply we can write taking that side, uh, q plus q by root 2 equals to minus q, right? Q if I take it as common, q if I take common, then 1 plus 1 by root 2 is equals to minus q, or simply I can write q into root 2 plus 1 divided by root 2 equals to minus q, or q is equals to minus root 2q divided by root 2 plus 1. So this will be the answer. D will be the answer. Right? Hope it is clear, all of you. I hope that it is clear. Any doubts in this one? How many of them got the answer? How many of them? Okay, good, good, yes, good, right. We'll continue this topic in the next class.